Today, we will still be looking at how do we expand or condense logarithm expressions. Now, we will use the same rules as we were using on the previous video. It's going to be pretty much the same skill, but now we're going to be looking at more challenging questions. So just a small review here. If you want to either expand or condense a logarithm expressions, we will be using the three rules, where the first rule says if you have an exponent, you can bring it in front of the log. That's what the first rule says. The second rule says that if you're adding two logarithms, that is equal to just multiply whatever they have inside. So log of y plus log of x, that is just equal to log x times y. And the third rule says that if you're subtracting, you can just divide the insides. Here the insides are the y and the x. So log of y minus log of x, that is equal to log y divided by x. So we will be using these three rules again, but now we're just going to be looking at more challenging questions. So let's get started. Now, here are rules, just in case we need them. So the first thing is we need to identify if we're expanding or condensing. Here, we're expanding. So our original problem, we need to just write it in more than one log. So let's see. When you're expanding, you need to see what's happening inside the log. Here, I notice three things. Here, I notice that we have log, and inside the parentheses, we have 12 times x to the third times square root of y. So notice that these three things, or these three expressions, are multiplying. So it's 12 times x to the third times square root of y. Because I'm multiplying inside the logarithm, I'm going to be using the rule 2. I'm going to go from right to left. So log of x times y, that's the same as just adding them. So let's do that. Every single multiplication, I'm just going to add them up. So now this means that if I want to expand it, this is equal to log of a, because that's what we have here. The first thing that I'm multiplying plus log of a. The second thing that I'm multiplying, which is x to the third, plus log of a times the third thing that I'm multiplying. Oops, that's supposed to be the square root of y. So we have here square root of y. Great. So at least we wrote it. Now, what we need to figure out is, can I do anything with the exponents? Because when you're expanding, you should not have any exponents. But before we move on, I want to remind you that the square root of y, notice that here your base is 2. Here, this is the same as y over 1 half. We saw this on previous videos when we're trying to rewrite square roots into exponents that have a fractional exponential. So now that means that this y, let me just rewrite that as exponent 1 half. So now, what do we know about exponents? If I have an exponent, I can just bring it to the front according to the first rule here. So let's look. First expression here, it doesn't have an exponent, so I'm just going to rewrite it. So that's log of a of 12 plus, but notice here the second expression, it does have an exponent, so we need to bring this to the front. So now this becomes 3 log of a of x, because that's what the rule says. If you have an exponent, it goes to the front, plus, notice that here we have an exponent of 1 half, so it goes to the front. Now this becomes 1 half log of a of y. And this is your final answer. All we did, we just followed the rules. I noticed that in the inside we were multiplying, so I add every single one of them. And I noticed that those which have an exponent, I need to bring that exponent to the front, and that's what we have here. So now let's look at the next example now. Kind of similar. So let's see. Let me move this here. All right. So let's see. What do we have here? Again, we're expanding. So you need to figure out what's going on inside the square, inside the logarithm. Notice that here I'm multiplying 5 times the cube root of all this. And according to our rules, multiplication is addition, according to the second rule. So let's do that. Let me separate them with addition. So we have log base 3, because that's what we have here, of the first thing that I'm multiplying, which is the 5, plus the log 3 of the second thing, or the second expression, should not be calling them things, the second expression that we're multiplying by. Okay, excellent. Now, every time you have a square root, try to rewrite it as an exponent. So remember that x, y to the second, the square root of this is the same as everything raised to the 1/2, because the square root you can rewrite as exponent. And now when you have an exponent, the rule of exponent says that it gets distributed. So now you have x to the 1/2 1 times 2 times 1/2, but this is just 1, so let's just rewrite it as 1. So I know that the square root of x y to the second, that's the same as x 1/2 times y to the first. So let's rewrite this. Now sometimes the complicated part comes with just rewriting the square root, not so much about the logarithm. So the square root of x y to the second, I can just rewrite as this. So notice that here I'm multiplying again, so I need to apply the rule of exponent, which says multiplication is addition. The first thing that I'm multiplying, x to the 1/2, plus the second expression that I'm multiplying, which is just y. So we're almost done. Again, in your answers, you should not have an exponent. Notice that here we have an exponent, and according to the rule of exponents, if you have an exponent, it should go to the front. The first expression does not have an exponent, so I'm just going to rewrite it. Second expression, it has an exponent of 1/2, so it goes to the front. Third expression does not have an exponent, so I should just rewrite it. And that's it. This is your final answer. Now lastly, let's look at the third example here. Well, let me bring down my rules. Okay, so notice this is a little bit different because we're not multiplying, but we are subtracting. Well, I already gave it away. We are dividing, and according to the rule of logarithms, if you're dividing, you can expand it as subtraction. So that's the first thing that I want to do. Notice that inside the logarithm we are dividing, so we gotta subtract. What do we subtract? Top minus the bottom. So now we're gonna have log 2 of everything that we have on top. So 3 x to the third, y to the second, minus log of what we have at the bottom. Excellent. But now notice here that the first expression, we are multiplying everything here. And again, the second rule says that if you're multiplying, you can just expand it as addition. So let's do that. So now we're going to have the following. Plus log of 2, supposed to be a 2. The second thing that I'm multiplying, which is x to the third, plus another log 2, y to the second, and still, I'm still going to subtract the third one here. log of 2 c to the fifth. All we did here, it just expanded the first expression here. We didn't do anything fancy here. All we did, we just expanded the third expression. Now we're almost done, because again, when you're expanding, you should not have any kind of exponent here. Let me erase this, this might be a little confusing. Again, once you have your final answer as this, your final step should always be putting exponents in front of the log. So let's look here. The first term does not have an exponent, so you just rewrite it. So now that just becomes log 203 plus, notice that the second, it does have an exponent, so we should bring it to the front. So now this becomes 3 log of 2 of x. We have an exponent, goes to the front as well. So now this becomes plus 2 log of 2 of y. And the third one, we have an exponent here, so it goes to the front. We still have this minus, so it's minus 5 log 2 of z. And this is it. And this is your final answer.